My name is Silvia Cruz. I am the coordinator of the Advanced Manufacturing Process Area at PIEP. PIEP stands for Center for Innovation in Polymer Engineering and was founded in 2000. We are a non-profit research and technology organization located in the campus of University of Minho, Portugal. And our core mission is to support the companies on their research, development and innovation needs so they can strengthen their competitiveness in the plastic industry and related sectors by providing our professional experience, our equipments, our infrastructures, our manufacturing tools, always basing our work on the promotion of the principles of a sustainable development. We have very complex projects, and in one particular case we used Moldex on a product development that consisted a system with very different parts that had to fit all together. Dimensional accuracy was essential. Also, due to the type of application, the selected material was highly loaded, make it very difficult to inject. In the beginning, we used Moldex 3T in order to optimize the geometry for injection molding. Likewise, once again, we use Moldex to support us on the design of the tools. Thanks to the software, we were able to do several virtual trials with testing different type of gates, sizes, locations, cooling systems. And only after we were confident on the results, we decided to go forward with the tool manufacturing. After the tool manufacturing, we used Moldex 3D to determine the most suitable processing parameters. And it was then during that study that we realized there were potential defects during production. In this case, the warpage that was not acceptable for this type of product. This helped us to plan ahead some strategic solutions to solve that type of problem or suggest minor corrections to the tool to overcome this defect in case the process parameters were not sufficient to solve this problem. In this project, Moldex was the tool key in order to us to achieve success in the project.
We could represent the cooling channels that we can see here. We represented the injection system. In this case, it is completed with a hot runner and then also a cold runner. And in this case, we have the part that is bicycle seat, and it is made with a polymer, with a plastic polymer, and also with an insert. In this case, a prep-reg, a pre-impregnated, that is included in a mold. So here we have the overmolding of the prep-reg. Maybe I can show you the mesh. This is the mesh that we have done. We represented the venting system. We can see probably here at the end the ejectors, the extractors, that also works as the venting system for this part. The physical mold that we had inserted some pressure and temperature sensors in the cavity. We did the same study and the same analysis here in the Moldex. These probes that we can see here in pink are the same pressure and temperature probes. We also used the machine that we have here. We also represented in the Moldex and then reproduce simulation. Here I can show you some results. System, and we observed, for example, the filling pressure, the filling profile. Okay. Things that we have seen, the pressure, the graphic pressure in the probes. We also did another process simulation with and without the venting, because in reality we had some difficulties with the venting, and we also reproduced that, and we have seen, for example, the same parts that were difficult to fill in the real mold. We could see that in the process simulation. We have compared the warpage and the dimensions of the parts.
So we have been using Moldex since 2017, and this enabled us to witness the evolution of the software, and we could assist year after year the increment of new features and functionalities. We noticed that Moldex 3D is embracing new themes like smart manufacturing, digital transformation, smart machining and artificial intelligence. And since this is also part of our strategic visions, when we look to the future, we see us continuously working with Moldex.